So what we're going to go through today is seabed preparation, clearing the way of the seabed for preventative measures for cable installation and foundation installation. So why seabed preparation matters? The only thing on on an offshore wind farm that you can't predict is actually the seabed when you get there. The first thing that you'll ever come across on any wind farm site is that there has to be cleared of the boulders, UXO and any seabed obstacles, which could be debris, installations, existing cables. So as part of that, obviously, how do we create that with that? So OEG provide the total seabed solution of clearance, which is obviously the UXO and boulder clearance as part of that. We do that by reducing the risk for the client, and many ways of doing that is actually by removing all the seabed ordnance, boulders that's on the site and ready to clear that as part of the system. Typical seabed risks, so obviously you've got the boulders and the glacial till. Glacial till is existing most of around the UK sites. The way the UK is formed on the seabed is actually glacial till, and it's obviously more prevalent in certain areas where we have a sandy seabed or we'll have actually hard rock as part of that, is where we move forward. Due to existing wars, First World War, Second World War, and obviously historical ranges on site, we have a huge amount of historical debris of wartime remnants, which is obviously the UXO. We have our own in-house team as part of that, where we can actually clear all the seabed of the UXO, and we're actually now using the low order deflagration, which is backed by the government now. This is the way they want to do it, but that's the way we're working. Hard ground variable geology, obviously that can be to do with the pile geology. This is all the different various areas of that. Sand waves and mobile sediment. So sand wave and mobile sediment can obviously very important to where you're doing your cable installation on the sediment side, where the different densities of the soils, it can be effective as part of that. Existing infrastructure and crossing, that's obviously where we've got the old existing cables that are all there that have to be rectified. Pipelines can also be on the site, where we move forward with that. And obviously historical wrecks and archaeology that comes as part of that. Where do OEG fit into all this? Obviously we provide all that service as part of that clearance to make the total seabed clearance as part of your project safe to move forward. So where does this on the site work during the construction? So obviously the first pre-survey, first thing that's always on site is actually surveyors. They come along, they survey the seabed for the various areas, and that can be the density of the soils, the geology of the rocks. Next phase of that is then how do we clear that site? This is where we come in more than anyone else as OEG. We come in and we can provide the total UXO survey, the UXO clearance, and then as part of that the boulder clearance and boulder prep. That can also be stuff such as PLGR, historical debris of drop debris from years ago where they used to throw everything off the side of the ship as part of clearance, and we can clear that. That then enables the site to move forward into the foundation installation and cable installation. Without having all the part of the preventative measures of the seabed clearance before that with the UXO clearance, you won't get the insurers to write it off, to the warranty surveyor. So as part of the insurance risk, we're preventing all that as part of that as way we move forward. Boulder clearance. So as you can see here, we have what they call a 5-tine grab. A 5-tine grab is our system that we use. The Subsea multi-tool is an ROV system-based system, work-class-based system. We can lift any boulder from 0.2 meters, which is the historical is what they're saying now, which is basically a pebble. So we can clear everything from a pebble to a very large boulder. What we can't clear is what we call the iceberg rocks. Iceberg rocks it looks like a pebble on the surface, but ultimately underneath it's a huge boulder. So we do get asked a lot on that. Can we clear them? And we also get asked, can we clear subsurface boulders? If we can't see them, we can't clear them. Simple as that. How many boulders do we do? Historically, depending on the density of the field. So if a site of the boulders is hugely dense, we can move 200 plus a day is the reality behind it is. But ultimately, we state with 80 to 120 a day. That's the average type boulders that we'll do per day on the site. So, if we tell a client, he says, I've got 10,000 boulders, so well, depending on the density of the site, we can remove 120 a day and we can clear that quite successfully and quickly. The biggest factor as part of that is the actual vessel transit. Vessel transit is ultimately what debates how much boulders we can clear per day. We have gone on sites where they go, we want you to move a boulder 100 meters away. If you think if you're moving the vessel backwards and forwards 100, that's 200 meters each movement for each boulder. We say stick to 20 meters outside. That's your cable corridor. Larger on the jacket foundations than the piling foundations, because obviously the jacket has various footprints, and we'll clear a big petal, as it's called, footprint petal, as part of that. But the transit is the key to all of this, how many boulders we can actually get per day, because the vessel solution is actually the main tool that we're using. Our boulder grab is literally going up and down, picking up the boulders and relocating it. We use the vessel more than anything else for the movement of actually the rocks. So it's always done by vessel. UXO, our second main activity. So we'll come in as part of that, we'll do the UXO clearance. First of all, we do a footprint squared area, so we'll grid the area where we've got historical. The client will give us a master target list. As part of that master target list, we then grid that area that we're going to clear to make sure that we're ensuring we're covering the whole area, usually a 10 or a 20 meter grid, depending on the client's regulations as part of that. We'll go in, we'll do the grid. The ROV goes backwards and forwards with a magnetometer. The magnetometer spots the target. The target, then we debury it with dredging systems, which is what you can see here. This is one of the dredge systems on its manipulator arm. It will then expose the target. Now, sometimes it can be masked, so if it's masked, we'll basically remove that masked area. That could be anything from an old car tire to a bit of steel. Ironically, something as small as a scaffold tube or something like that's just been thrown over the side. We pick that area up. That then gets removed away from the target. We then go back and do a second clearance to ensure that it hasn't been masking a potential UXO underneath. Once that's cleared, we then can issue the ALARP certificate for the client saying that particular target that you've identified for investigation is now safe and clear for you to install cables, foundations, or what have you. So the main method that we're using currently now, and it's been brought in through governmental change, is the low order deflagration. Low order deflagration is where you fire a shot into the UXO target, whether it be a mine, a shell, airdrop weapon. There's a whole variety of different UXOs that are out there. And what we do is we fire a shot into that. It's a magnesium shot that's fired at high velocity as part of the explosion, fires into the shell. Due to the power of it, zooms around the shell, if you want to put it another way, burns all the explosive out, and then cracks open the shell as part of that. That then, basically, we send the ROV back, it looks at it, sees it's destroyed, and then we recover them all to the deck. So whereas before we'd blow them pretty much to smithereens and there'd be nothing left but, bits of iron filing, if nothing more. Nowadays, we actually recover a lot of the shells. Client sees it, it gets thrown into a skiff and then gets taken away for disposal once we bring it back to the beach. Cable route preparation. So again, all within our arsenal of tools that we have. We have pre-lay grapnel trains, which is a large anchor type system. There's various types that you can use for that. And basically we'll then pre-lay, so for cable installation, if there's existing cable, we will then drag the grapnel train through the sands. It will pick up the old redundant cables that may be lying around, fiber optics, pick them up, cut the cable, remove that out way of the path. Boulder clearance en route, again, we've just discussed that, where we're then part of that. All this can actually be operated, I wouldn't never say a singular vessel, it would always be a two-vessel operation, mainly because usually there's that many boulders and that many UXOs on site or investigations to do. We've got to clear all that area as part of that clearance area. We also have the Seabed system. The Seabed system is the controlled flow excavation system. It's the world's first electric oil control flow system. So for seabed levelling, in the UK, I'll talk about that mainly here. That's mainly in the southern sector of the UK, where you have shifting sands, moving sands, and they can actually move at over 1 metre in height as they move along. Sometimes even more than that, 2 meters. I've actually physically watched a moving sand wave go that was over 0.5 metre, and it's literally rolling as it's moving forward. So they do move very quick. So where you may have a buried cable, for instance, that sand wave can actually debury that in the space of 6 months, the whole length of the cable, and cause a problem. Hence why now they are looking to bury them deep, especially in these moving sand areas. Move on. Where are we now? Debris, heritage, legacy. So not just that, what we often find, we found everything from 17th century cannons on these sites to old World War II planes that have gone down. So archaeology is part of that. So as soon as you find that, it causes a bigger problem than UXO, because then all of a sudden now it's historical data, someone's got to record it, and it slows the project down. So when we do find these, obviously we've got to detail them, be very careful that what we're saying is correct, because if we say it's a bomb and we blow it up and it seems to be a 17th century cannon, it puts a lot of people a little bit angry, if you want to put it in another word, and we move forward from there. So we generally have archaeologists on board as part of that, as part of the train. So if we do find something we're unsure of, that could be marine growth on board, it could be rust, it could be a whole host of things that have caused obstruction for us to positively identify that target. When we do find it, obviously it's identified, usually brought back, or usually they will say leave it where it is. It's archaeology, leave it there. I know on one particular site, the 17th century cannons and the cannonballs that were around it, they were left. Whether somebody went and stole them afterwards, I don't know, but that's a story. So what do we use as part of that? Work class ROVs. So OEG currently have long-term frameworks with work class ROV. We have our own observation class ROVs as part of that. So the work class ROV, what do? We put on that, we have a magnetometer on the front, we put low-level cameras, because obviously when we're dredging the system, you get a lot of silt and sediment that gets kicked up as part of that, and so we need to identify the target. So we put low-level cameras on the front of that, on the manipulator arm. It usually has a 6 or an 8-inch dredge system to debury the system where we are. And again, this is all in usually sandy areas. If it's a hard rock glacial till area, we're usually quite fortunate that usually they're sitting on the surface on the actual bed itself. All done remotely in the deeper waters. However, we haven't moved away from using divers in the shallow water yet. We are looking at existing technology to bring in remote systems for shallow waters where we can drive it down the beach into the water, do the clearance as part of that, and then take that away. Our own Subsea multi-tool, it's the Swiss Army knife of a ROV, is another way of putting it. So basically the system it's a bolt-on system, and as you can see there, you've got the tine grab, and what we've got is a rock bag installation cruciform. So on one site, we can do multiple of tasks with this. Everything from, again, removing the pebbles, and we have a clamshell grab, which is a big bucket type grab type system, the tine grab, mattress installation tool, so we can go along on one project with one vessel. We can do a multiple of tasks as part of that when we're going forward. Our system, where it does it as a whole suite, it has 6 different various survey systems, Ethernet systems built into that. So when we're looking at the system, we can plug in multi-beams. It has blue view systems, low light cameras. So every target that we actually identify with this system, it takes a picture of it, logs that on part of the data. A whole report is then generated where we've picked it up, moved it to, and placed it down. So then the client has a total record, usually within 24 hours, as we're moving on the cable paths or the jack-up places. Everything's moved, data logged, recorded, videoed, photographed. That's 2 phases. A, we give ourselves the confidence that we can show the client, if he ever comes back to us, well, we found the boulder there, we go, oh, that one's been moved. Some of these huge tidal areas actually do roll boulders back into them, believe it or not, especially with the moving sands. Move on. So a typical project, Sea Green project, we had to move, initially we got engaged to move 10,000 boulders. We ended up moving 46,000 boulders plus by the time we'd finished. And it was a very unique project because we was actually working for the developer plus the tier 1s on the same project doing the same task. But because they wanted to accelerate the project so quickly, we had 3 vessels on site doing at the same time because they had a timeline of get the boulders removed. And again, this goes back to if they do the pre-survey, give us the information earlier, get us on site earlier. It works a lot better for the project and clears the project of any problems they're going to have before cables go in and debris, foundations go in. So result overall, so to date we've actually removed over 1 million boulders on sites across UK wind farms, and that's UK alone. So if you going back from 2016, so in the last 10 years we've moved over 1 million boulders on site. So it is a problem. It was something that was forgotten about early on or ignored. However, again, marine warranty surveyors, insurance as part of the project has to be done. Why do we do it? Very simple, failure costs. So if the client has forgot Strange enough, they still do forget to do some of this. Missed UXO, that's a stop work order. If there's a UXO found on site by a cabler, they stop work. Cable installation vessels, probably around £200,000 a day, they just stop and they'll wait till someone turns up, and that can be a week, a month, it can be a whole. So if you're thinking on the cost of that, our actual cost in comparison to what this would cost to do that is minimal when it comes to it, minimal. UXO boulder found, installation delay, again, the jack-up vessels, huge cost to the project. If they haven't cleared the field properly, a boulder's left behind, punctures a jacket, he then has to go back into the beach, has that repaired, all on the client cost, delay, delay, delay. Poor burial if the site hits a boulder, that gets stuck in its plough or jetting the system. Again, it won't work, that's why we have to get all these moved. Unknown debris, that could be anything from ironically containers, all sorts of stuff that's fallen off the side of a ship. Vessel standby time, waiting, all of this backs the client cost. The whole point of this is what we built the whole business on originally. Seabed clearance was preventative measures to stop the client or the Tier 1 contractors ultimately from delay. So what have we learned? Survey, get in, survey early. We tell every client, get your survey done as soon as possible. Give us the information as soon as possible. As part of a tender process, fine. Give us that information. Even today, we're still getting the information when we're on site. We are then chasing our tail, they're chasing their tail. The cablers are already starting to arrive on site. Bills are starting to arrive. Give us that survey early. The sooner we can get that survey information, the better. Clearance survey in one pass. We come in with the two-vessel solution for the UXO clearance of the boulder. We can do it from one vessel. I don't think it's a good solution. Yes, it saves cost, but then you're going, well, we need the UXO done over there, we need the boulder done over there. Two-vessel solution, we have flexibility. Flexibility to clear the boulders, to clear the UXO. We can move anywhere on that site and get it cleared very quickly. We can verify the burial conditions. Some of the UXO, the density of the sands and sediment that we can go and do, and the tidal areas that we go to work in, for UXO especially, not so much boulders in this case, the density of the soil says how quickly we can debury that particular target. Some days it can take 5 days to actually debury a target, because due to the tidal range and the fine sediment of the sand, it reburies and sets like concrete again, and that target's buried again. So we can only work during the slack periods of the tide. Treat the clearance as a gate. The clearance spread is cheaper relative to the foundation and cable vessels waiting beyond. Again, we are minute in comparison to the cost of delay, always. Plan dump zones and transits. Plan them before we get there, because ultimately we get there and we go, okay, we can't blow this up, it's an unsafe object, so we're going to try and move it and shift it to an area outside of a known dump area, as we'd call it. We can then pick up those UXOs, and transit them to an area where they can be classed as safe within the wind farm, and then just dumped again on the seabed. Sometimes we won't do that. Generally we blow everything up nowadays, but the reality behind it is, it's sometimes quicker to pick it up, move it, and dump it into a safe area. Contract the interface explicitly. Be clear who owns the standby, weather and foundation and found conditions before anyone gets offshore. Historically, we've arrived offshore, confusion, they thought it's in the contract, we've clearly showed them it's not in the contract, then there's an argument, and then we're in back to the stage one where we're going, who's responsible for that? Time, cost, money, everything else, we move forward. Always gets end, someone's got to pay for it somewhere along the line. 5 things to take away. Seabed preparation buys down the project's most expensive least viable risk with that. Most failures are created at installation, and most are preventable upstream before we even start our work. So if we've done all the clearance, preemptive, huge cost saving, and you do it mainly where the foundation, this would come in. So where the foundation gets installed, jack-up operators historically want to change their footprint. So we then say, well, give us a 200-meter radius to clear. If we can clear that whole area, doesn't matter where the jack-up goes, it's clear. Clearance is a schedule gate that protects your most costly vessels. Says it all on its own in that one sentence. If we've cleared the area, there's no delay with cable or foundation or jack-ups. Technology is consolidating spreads and producing a verifiable data trail. The data we give you, the technology we have now with all the survey data on board, gives you instantly, within 24 hours, we've told you that area is clear. The cheapest risk is reduction of the whole project happens before the steel hits the seabed. So in theory, if we've cleared that seabed before you even put any steel on the seabed as part of your project, then you have no problems with installation, the foundations, cables, burial, it's all already cleared. What's next? Bigger, deeper floating, so we're moving that. However, they still need the clearance, UXO need the clearance. The cables still get laid on the seabed, even on floating wind farms, they still go down and move, and it still has to be cleared. Consolidation and automation, we are now looking at ways to autonomize our systems. Surveyors on the beach, not so many people, reducing the manpower risk offshore. We're looking at ways, inventive ways of doing that. Tighter environmental envelope, low order. So again, we've said we are innovators in bringing low order to the market. We use low order deflagration as part of our systems. Data-led delivery. Everything we do now is printed on Excel sheets and taken away from that and passed on to the client. Within 24 hours, he knows that he can then tell his construction vessels, installation vessels, he can move forward. The decommissioning crossover, where we're moving to it. Our systems are developed to do decommissioning. The whole purpose of our system's original build was for salvage. Ultimately, if it comes into the decommission market, we can do the dredging systems, we can do the cable cutting, we can do the repairs, all with remotely from part of our systems. Risk reallocation. Insurers and lenders are pushing standards, i.e. the DMV standards, and burial discipline. They're asking to go deeper. They now need to UXOs in theory that we've been asked to do up to 5 meters depth, which is if you've got to debury down to 5 meters, that's a very large hole that you've got to clear. And that's me done. Thank you very much.